Hello, today you are watching the PowerPoint on what does a scientist look like and what is a scientific method. You will be watching this video at home instead of listening to the PowerPoint during class. So first let's talk about what does a scientist look like. Maybe like him. This guy is Albert Einstein, and he was a theoretical physicist. He's famous for his formula E equals mc squared, and one of my favorite quotes from him is, "I have no special talent, I am only passionately curious." I think that gives us a lot of insight into what kind of scientist he was, and that he used his curiosity to generate all of his scientific questions. So he's one type of scientist where he came up with a lot of theory and tested a lot of his theories, and we're still testing them today. Another scientist is this woman, Marie Curie, and I know she looks a little harsh, but she was a great scientist. She won the Nobel Prize in 1903 with her husband, and then she won it again in 1911 all on her own. Her research with radium has been put to use against cancer, and if you've ever had an x-ray, you've used her scientific findings. One of my favorite quotes from her is, "Life is not easy for any of us, but what of that? We must have perseverance and above all confidence in ourselves. We must believe that we are gifted for something and that this thing must be attained." So you can tell that she was a hard worker. Another one of my favorite quotes from her is about if people want to give her gifts, don't give her a dress, give her something she can wear in the lab. I think that's kind of a funny thing. So she's another type of scientist, someone who spent her whole life in the lab researching and researching. Here's another scientist. You know this guy. This is Bill Nye. And you've probably seen some of his videos in some of your science classes. So he is the science guy. And what a lot of people don't know about him is that he used to design fighter jets for Boeing. And so he was an engineer. That was kind of the scientist that he was. He was very hands-on and did a lot of designing and engineering. And a great quote from him is, "Leave the world better than you found it. Sometimes you got to pick up somebody else's trash." He has turned into somebody who is a huge advocate for the earth, and he's a type of scientist who tries to inspire scientific thinking and creativity in kids. And here's one of my favorites. This is Jane Goodall. She was famous for living with the chimps, and she is still the world's foremost authority on chimpanzees. Today, she is still very active with animal welfare and rights. And she said, "If you really want something and really work hard and take advantage of opportunities and never give up, you will find a way." She didn't start out as a scientist. She started out as somebody who was really interested in chimps, and so she just dove in there and worked for someone who was a research scientist, and she just decided to spend her life in the jungle, and so she has made quite a few discoveries just by working hard and having a lot of passion. So the scientific method, this is something that you have learned about in science class before. Today we're going to talk about what is it, how do I use it, why would I use it, and is it hard? So first we're going to take a look at a quick little video.
Yeah, I know you've been watering it. I'm not sure what's wrong. Dear Tim and Moby, what is the scientific method? From Marcy. The scientific method is the procedure scientists use to help explain why things happen the way they do. When people are trying to understand the world around them, they often come across problems that they just don't know the answers to. This is where the logical, step-by-step method of scientific problem solving comes into play. Like Moby here, he seems to be having a problem with his plant. The first step in scientific problem solving is to recognize the problem. Right. The plant is dying even though it's getting water every day. Why? To solve this problem, we first need to understand what we already know. Okay, plants need water. What kind of plant is that? Fig tree, right. Now we need to make some observations about the plant. The leaves are brown and falling off, and the soil is wet and squishy. Next, we make an inference. An inference is a conclusion about our observations. From what we've observed, we could infer that Moby is watering his plant too much. Now we translate our inference into a hypothesis. Well, a hypothesis is a testable explanation for the details you observe. What about fig plants do best if you only water them once a week? Sure, it's just a guess, but after our observations, at least it's an educated guess. We'll need to come up with an experiment to test this hypothesis. Here's the plan. We've got 4 healthy fig plants marked A, B, C, and D. They have the same type of pot, the same soil, and they're getting the same amount of sunlight. The only variable, or thing that changes, will be the amount of water they receive. Plant A will not be watered at all. Plant B will be watered every day. Plant C will be watered 3 times a week. And Plant D will be watered just once a week. We'll check back in a month to see what's happened. What do you know? It's been a month, and I'm still wearing the same shirt. Let's record some new observations. Plant A doesn't look too good. Plant B doesn't look so hot either. Plant C looks a little better. Whoa there, Plant D is doing all right. Time to analyze our data. Based on this experiment and our observations, it looks like the fig plant did best when it was only watered once a week. From that, we can make a conclusion. Of the 4 watering schedules we tested, fig plants seem to grow best when they're watered once a week. Well, yeah, to be really sure, we should repeat this experiment several times just to rule out accidents and variables we may have forgotten to consider. If the experiments don't support the hypothesis, then the hypothesis has to be rethought. Back to the drawing board, so to speak. But if lots and lots of experiments do support the hypothesis, then that hypothesis can eventually become a theory. Well, in science, a theory is an explanatory statement that's been repeatedly confirmed through experimental testing. If a theory is proven valid over and over again, it becomes an accepted piece of scientific knowledge. In the strictest sense, there's really no such thing as scientific fact. Scientists are always learning new things about the world around us, and you never know when they may find some new bit of evidence that forces us to redefine our understanding of the world. Right, using the scientific method can help you be right more often, and not just in science class. You just have to make sure you do all the steps. If you form a hypothesis without making any observations, then you really are just guessing. And you'll never know if your hypothesis is true or not without testing it with an experiment.
So, to review what you just heard, the scientific method is a set of steps to follow, and this poster here kind of shows an outline of those steps. First, you state the problem, then you research to find out more about the topic, then you come up with your hypothesis, where you predict what you think the outcome will be, then you carry out the experiment, then you analyze your results, and then you come to a conclusion where you determine whether or not your hypothesis was proved correct or not. Now, these different steps can be stated in lots of different ways, but they're basically the same process. So we're going to look at each of these steps a little more in depth. Now the purpose is where you're stating what it is you want to learn. An example might be which doorknob in the school has the most germs, do girls have faster reflexes than boys, or does the color of a light bulb affect the growth of grass seeds? So it is a question that you want to investigate. Then you're going to do some research and find out as much as you can, and this is usually done by looking in other books, on the internet. Sometimes it's just a matter of talking with other people to see their opinions on it. And then you come up with your hypothesis after your research, and this is where you try to predict your answer to the problem. Sometimes we call this an educated guess, and you can have it as an if-then statement. If I do this thing, then this will occur. So an example would be, if I grow grass seeds under green light bulbs, then they will grow faster than plants growing under red light bulbs. So you are stating what you think the outcome will be. Then you get to carry out the experiment, and this is where you design your procedure and spell out all of the steps of what the experiment is going to be. So with this grass seed example, you would set up grass seeds under a green light bulb and under a red light bulb and compare them with each other and observe for a few weeks. You would also set up grass seeds under a regular white light so you can compare it with the others. This is called your control group. It's important to have a control group in any experiment. You also want to make sure that for your seeds that are under all 3 types of bulbs, that all other variables are kept the same. The only variable that you want to change is the color light that they're grown under. You want to make sure you use the same seeds, the same soil, they're in the same room, and receive the same amount of light each day. After you've carried out your experiment, you're going to record all of your results and then analyze what's happened. You're going to take your data, you're going to take a look at it and say, does this seem reliable? You'll organize it into a graph so that you can better take a look at it, and then you're going to take a look and see if it supports your hypothesis. And this is when you come up with your conclusion. So you want to see if your hypothesis was correct. It's always important in the conclusion that you're stating, my hypothesis was proved correct, or my hypothesis was proved incorrect because. So, for example, if the grass under the green light bulb grew faster, then you proved your hypothesis correct. If not, your hypothesis was wrong. It's not a bad thing to prove your hypothesis wrong, because whether you proved it right or wrong, you've learned something. So again, these are those different steps to the scientific method, and we'll go over these in class some more. So, how do we use the scientific method? What we're going to do now is just kind of virtually do a little scientific experiment and follow the scientific method. So if you read the little paragraph there, it says that a horticulturist, which is a plant scientist, complains to the city that a nearby resident is ruining his flowers because of the detergent being used to wash their cars. The soap runs into a stream that goes near his flower beds. As an inquiring scientist, you want to find out whether soap can affect flower growth. So there's the problem that you're investigating. You will need to set up your experiment using the animation below and publish your findings. Well, we're just going to talk through them. There's nothing that you need to write down. So we have our question, does soap affect flower growth? So our hypothesis will be, if soap is introduced to a plant, it will negatively affect the growth of a flower. Now we need to set up our experiment. So we need to design our control group and our experimental group. So first we get to choose what type of flower, and you can have a choice. We'll choose marigold. And you just want to make sure it's the same for your control group and your experimental group. Now you choose your pot, and remember, we're only trying to see if soap affects flower growth, so we want to keep all of the other variables the same. So we could do plastic and plastic, and then soil, let's do this potting mix and the same potting mix there. Now we have to determine about adding detergent. Well, in our control group, we do not want detergent. That's our control where we're not changing any variables. In our experimental group, this is where we want to test and see if soap affects the growth. So we do want to add soap to our experimental group. So now we've carried out our experiment and we want to collect some data. So we're going to take this ruler and see that these are about 5.5 centimeters. And the ones with the soap, oops, here we go, only grew about 2.5 centimeters. So we might put our data into a table, and then we can analyze the results and come to a conclusion. So our conclusion would be that our hypothesis was proven correct because the plant was negatively affected, its growth was negatively affected by adding soap. Now, is it enough just to do one plant in the control group and one in the experimental? Probably not. It's a good idea to replicate your experiment and do it many, many times. So why would I use the scientific method? Well, remember Einstein? This guy? He said, I have no special talent, I am only passionately curious. If you're curious about things and curious about the world around you, then you're going to use the scientific method. Hello, Earth Science. That's what we're doing this year in science class. We're going to wonder about the world around us and use the scientific method to figure some things out. So, is the scientific method hard? Well, sure, it's sometimes hard, but it's worth it. Remember the puzzle that we did in the first couple of days of class? It got really challenging when we added that fifth piece, but it was pretty fun to be able to figure it out. So the last thing we're going to do is watch this cool experiment to see how fun the scientific method can be.
Tap, 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 no. 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 Tap, 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 no. Tap, 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 no. Tap, 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 no. Tap, 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 no. Tap, tap,
So do we think those guys just randomly threw some Mentos and Coke together and just kind of hoped it would all work out and the timing would be good? Probably not. They probably used the scientific method and tested over and over and over again to see how many Mentos it would take and what kind of Diet Coke and what size and where to put them and how to time it. They probably tried that over and over and over again, which is part of the scientific method. You make a hypothesis, you test it out. If it works, great. If it doesn't work, you go back to the beginning and try again. And so sometimes you can do some cool stuff with the scientific method. So as a quick review, the scientific method involves many steps. You start out with stating your problem that you're going to investigate. Then you do some background research to help you out to find out more about the topic. Then you come up with your hypothesis or what you think is going to happen. Then you carry out the experiment. You gather your data and analyze it, and then you come up with a conclusion where you're saying whether or not your hypothesis was proved correct. So hopefully this taught you a lot about the scientific method, and when we meet next in class, we'll be practicing this a little bit. Thanks for watching.